Lesson 8.4, we are going to simplify rational expressions. So first thing, just a quick review on multiplying fractions. When we have fractions, we multiply the numerators straight across and the denominators straight across. But whenever you can cancel, you should do that. Like 5 goes into 5 once, 5 goes into 10 twice. The 3 will cancel with the 12. And the 2 and the 4 will cancel. So now in the numerator we have 1 times 1 times 1 is 1, and 2 times 5 is 10. So multiply straight across. Remember, when we divide fractions, we multiply by the reciprocal. So when we have 15/4 divided by 10/12, that's really 15/4 times 12/10. And cancel when you can. Let's see, 5 goes into 10 twice, 5 goes into 15 3 times. And now multiply straight across. So you have 9 halves for an answer. Okay? Oops. All right, when we're working with rational expressions, that is the quotient of two polynomials. And here are some examples. These are in simplest forms, and over here we have problems that are not in simplest forms, which need to be reduced. So let's look at this first example. How do you put it in simplest form? Well, the first thing that we want to do is factor the numerator and factor the denominator. So you have x times x. 5 times 2 gives me 10, and 5 plus 2 gives me 7. So we'll just cross that out. Now we'll factor the denominator if we can. Let's see, 5 times 2 gives us 10, and minus 5 plus 2 would give me the negative 3 in the middle. So this is just a really good review of your factoring. So now, just like we did with regular numbers, cancel any common factors. So the x plus 2's will cancel, and we're left with x plus 5 in the numerator over x minus 5 in the denominator. So that's the answer. Yeah, that's your simplified form. The other thing that we need to address is the problem says state any restrictions on the variable. Well, the value that we never can have in the denominator is 0. So what we do is we look back into the problem where it's factored, and we look at those factors and set each of those equal to 0. So if x minus 5 equals 0, x would equal 5. And if x plus 2 equals 0, x would equal a negative 2. However, we don't want 0 in the denominator, so we say that x cannot equal 5 and negative 2. All right, here are a few examples. This first one, we just basically have a product on the top, a product on the bottom. There's no plus signs or minus signs, so we just start canceling because we have factors. So 6 goes into 6 once. 6 goes into 24 4 times. And then we have x cubed in the numerator and x squared in the denominator. So 2 x's will cancel out totally, and if we cancel 2, we have 1 left on the top. Here the y squared cancels, and if you cancel 2 y's, you just have y to the 1 power on the bottom. So in the numerator, you have 4 over y, and there's a negative 1, so we can just put the negative by the 4, or you could put the negative by the y, it wouldn't matter. And did I lose my x? And there's an x up here also, right here. Make sense? So let's look at example C here. So you have 12 minus 4x over x squared minus 9. Well, first of all, x squared minus 9, hopefully we recognize that that is the difference of 2 squares. So that would be x plus 3 and x minus 3. And if you look at the denominator, or excuse me, the numerator, we have a number and an x term. They're in the opposite order. So the first thing we're going to do to simplify that is switch those around. We're going to write negative 4x plus 12. because that'll make it easier, I think, for us. Now, as you look at this expression, what could you factor out of both terms 4 and negative 12? A negative 4. Always take the negative out, and so you would have a positive x, and 12 divided by negative 4 is a negative 3. And at that point, we can cancel the x minus 3's. So negative 4 is in the numerator over x plus 3 in the denominator. And again, we want to look at the restrictions here on both of these problems. So if x plus 3 is set equal to 0, x would equal a negative 3. And if x minus 3 was equal to 0, it would equal a positive 3. So x cannot equal plus or minus 3. And going back to this one right here, problem A, we have an x squared and a y squared in the denominator originally, and neither of those can equal 0. So we just say that x and y are not equal to 0. All right, the next one is a multiplication of rational expressions. And so we could multiply these out, the numerators out, but that would get pretty messy. And multiply the denominator out, that would get pretty messy. So it's going to be easier if we can factor first and cancel any common factors. So what we want to do is factor the numerator. So that would factor into x plus 3 and x minus 2. And then we look at x squared minus 25. That's the difference of two squares. So that would be x plus 5, x minus 5. And then lastly, x squared plus 4x plus 3 factors into x plus 3, x plus 1. And now we'll go ahead and cancel. We have an x plus 3 in the numerator and x plus 3 in the denominator. An x minus 5 and an x minus 5. So in the numerator then, we have x minus 2 over x plus 5 and x plus 1. Now in this particular problem, because they're asking us what is the product, that means multiply everything together. So once you've canceled out the common factors, then go ahead and FOIL the numerator. So it would be x squared, see, plus 5x minus 2x would be 3x minus 10 over x plus 1. So that's your final answer there. And again, we do need to look at our restrictions. So we go back to looking at each of these factors here in the denominator. So x cannot equal 5 or negative 3 or negative 1. And then we'll just go ahead and do one last one. This one is a division problem. And so again, just like when we're working with real numbers, we want to multiply by the reciprocal of the second term. So the first term is 2 minus x over x squared plus 2x plus 1. And then times, we'll write the reciprocal, x squared minus 1 over x squared plus 3x minus 10. And now again, we want to factor everything. And here we have the difference of two squares. Here we have a trinomial that will factor into a binomial. And then the top term here on the left in the numerator, again, the x and the number are the opposite, and so let's switch those around and write them as minus x plus 2, first of all. So I'm just switching the order. And because the other terms are a positive x plus something or minus something, we're going to factor out a negative. And what's kind of nice about here is I think, where should the x minus 2 be? There's a mistake in the denominator. This should have been a positive 5, and this would be a negative 2. Because 5x minus 2x would give me the 3x. And at that point, I will cancel. So I have x minus 2 will cancel with x minus 2. X plus 1 in the numerator will cancel with one of the x plus 1 terms in the denominator. So I'm left with negative 1 times x minus 1 over the factor x plus 1, x plus 5. And then I need to write the restrictions. And again, I look at the denominators of the problem. And x cannot equal negative 1, negative 5, or 2.